Alright, on to matrix multiplication. This involves multiplying two matrices by each other. So recall what I said previously in scalar multiplication. In scalar multiplication, we were taking a matrix and multiplying it by a constant number. Matrix multiplication is different. Now we are multiplying two matrices by each other. In matrix multiplication, the order in which the matrices are multiplied is very important. Okay, so the order is very important. A times B might be different from B times A. It's going to depend on the matrix, and it also dictates whether we can even calculate B times A. So the order, right now, what I want you to know is that the order in which we multiply matrices is very, very important. So let's consider the following matrices. I have A, which is a M by N matrix. So it has M rows. Now I want you to write this down, and it has N columns. Okay, write out its dimensions and how many rows it has and how many columns it has. Then I have the matrix B, which is N by P. So B has N rows. So notice how B, the number of rows it has, matches the number of columns that A has. And B has P columns. I'm just going to write col for short, cols. There we go. So notice this. This number of columns and this number of rows in the second matrix, they have to match. AB is an M by P matrix. And I'm going to explain how this works just now, how to remember the dimensions of the resulting matrix and what needs to match. I'll give you a trick. Note that to multiply a first matrix by a second matrix, so there's the first, there's the second, the number of columns in the first matrix, here we go, n columns, must be equal to the number of rows in the second matrix. There's the number of rows in the second matrix. If this condition is not met, the matrices cannot be multiplied by each other. You can't multiply them if this condition is not met, sorry. So the resulting matrix will have the number of columns of the first matrix. So this is M by P, number of, not columns, rows. Okay, rows, and yeah, it's mixed up here. There we go. So the resulting matrix will have the number of rows of the first matrix, so M rows, and the number of columns of the second matrix, so P columns. Okay, that's how you remember it. So just remember, it's number of rows of the first matrix and number of columns of the second matrix. Let's look at matrix multiplication. So remember that when I was doing scalar multiplication, it's different because in scalar multiplication, we were taking a matrix and multiplying it by a constant. In matrix multiplication, it involves multiplying two matrices by each other. So we're taking matrix, the first one, and multiplying it by the second one. Now in matrix multiplication, the order in which the matrices are multiplied, that is very, very important. Okay, so it matters what's the first matrix in the multiplication and what's the second matrix in the multiplication. So let's look at it. I want you to consider the following matrices that we are going to multiply. I have matrix A, and that is M by N. So I want you to take note that matrix A has M rows and it has N columns. I want you to write this out. And we are going to multiply it by matrix B. Matrix B has N rows and P columns because it's an N by P matrix. Let's just put a line here so I can separate it and see the two. When I multiply matrix A by matrix B, matrix A is my first matrix and I multiply by matrix B, I'm going to get a new matrix called AB, and its dimensions are not going to be the same. Okay, it's not necessarily the same. It is going to be an M by P matrix. Okay, don't worry about the dimensions of the resulting matrix. I'll show you an easy way to get it. So note that to multiply a first matrix by a second matrix, the number of columns in the first matrix, so let's look at the first matrix, we had n columns, it must be equal to the number of rows in the second matrix. There's the number of rows in the second matrix. these two must be equal. If this condition is not met, the matrices cannot be multiplied by each other. So they can't be multiplied by each other. The number of columns in the first matrix and number of rows in the second matrix, they must be equal, they must match. If they do not match, you can't do the matrix multiplication. The resulting matrix, if you can multiply the other two, it will have the number of rows of the first matrix, so there's the number of rows of the first matrix, M, and the number of columns of the second matrix, there's it there, P. That's why we have an M by P matrix. Okay, so that's matrix multiplication in a nutshell. Let's go on to an easy way to try and check if we can multiply two matrices by each other. And this is best done using an example. So I have matrix A, and that's 2 by 2. So I want you to write out its dimensions. It's 2 by 2. And I have matrix B, and that's 2 by 3. The question is, can we find AB, that is matrix A multiplied by AB? And if so, what are the dimensions of the resulting matrix AB? So the steps to identify if the first matrix can be multiplied by the second matrix, and just a note, I'm always saying first matrix, second matrix. You can do matrix A times matrix B times matrix C. You can have multiple matrix multiplications. I'm just doing it in terms of first and second because it's the easiest to explain, but these rules will always apply. Okay, so step one, I want you to write down the dimensions of both matrices. In the above case, we have a 2 by 2 and a 2 by 3. There we go. The inner numbers are the same. So the inner numbers, what I mean by that is the numbers that are on the inside. Okay, so if you write it out 2 by 2 and you have a 2 by 3, the inner numbers are this one and that one. It's on the inside. Okay, they are the inside numbers. If these inside numbers or the inner numbers are the same, then yes, you can find you can perform the matrix multiplication. In other words, we will be able to find AB. So that's a tick. It's 2 and 2. Okay, remember the number of columns of the first matrix must match the number of rows of the second matrix, and they do match here. Therefore, the matrices can be multiplied by each other. AB will have a dimension of outer numbers. So I have a 2 by 2 and a 2 by 3. So it's going to have the resulting matrix AB is going to have this dimension, the outer numbers 2 by 3. So it will be a 2 by 3 matrix. It will have the number of rows of the first matrix and the number of columns of the second matrix. That's why we get a 2 by 3. So that's an easy way in terms of inner and outer numbers about how to identify if you can in fact do matrix multiplication. All right, that's enough explanation. Let's actually see how matrix multiplication works. All right, here's exercise 1. You have matrix A, matrix B. So I'm going to take you through the process of finding A times B. Okay, let me show you how to do this. So I'm going to write this out, 2, 3, 4, 1. Remember, it's A times B. So we have to write A first and then B. Order is important in matrix multiplication. Okay, and then we'll have 2, 3, 1, 0, 4, 1. Okay, firstly, let's just check that we can multiply them out. So it's a 2 by 2, and we have a 2 by 3. So the inner numbers match. Yes, we can multiply them out. And what's the dimension of the resulting matrix? It's going to be a 2 by 3. That's the outer numbers. So I know that my resulting matrix is going to be a 2 by 3. Now, I'm going to go through it very slowly, step by step. This is how you multiply it. So the resulting matrix is going to be 2 by 3. So we have 1, 2, 3, 4, 5, 6 entries that we need. Let's start with row 1, column 1 in the resulting matrix. So that's row 1, column 1. To get row 1, column 1, we are going to look at row 1, column 1 in the two constituent matrices A and B. Then we work left to right, top to bottom, or we multiply from left to right, top to bottom. What do I mean by that? So I'm going to take the 2 and multiply it by 2. So I'll get 2 times 2, that's equal to 4. Then I'm going to take the 4 and multiply it by 0. So I'm going to get 4 times 0, that's going to be 0. What do? I then add these numbers up. So that's going to be 4, and that is the answer for row 1, column 1 of my resulting matrix. Okay, simple. Let's do it again if you didn't get it, and we'll apply it now. So now I'm looking at row 1, column 2. Row 1, column 2. When we multiply matrices, we always multiply left to right, top to bottom. What does this mean? I'm going to take the 2 and multiply it by the 3. So it's 2 by 3, that's equal to 6. Then I'm going to take the 4 and multiply it by 4. That's 4 times 4 equal to 16. Add the answers that you get. You have 22. There is row 1, column 2. Simple. Let's do it again. Okay, now I'm looking at row 1, column 3. So row 1, column 3. When we multiply left to right, top to bottom. So it's going to be the 2 multiplied by 1. That's going to be 2. And then it's going to be the 4 multiplied by 1. That's going to be 4. Add them up, you get 6. That's the answer for row 1, column 3. Okay, let's move on. Okay, now we are looking at row 2, column 1. Row 2, that's a bad circle. Row 2, column 1. When I multiply left to right, top to bottom. So it's 3 multiplied by 2, that's 6. And it's 1 multiplied by 0, that's 0. Add them up, you get 6. There's your answer, 6. Okay, we're getting there. Let's do it again. So we are looking at row 2, column 2. So row 2, column 2. When we multiply, it's left to right, top to bottom. So it is 3 multiplied by 3, that's 9. And it is the 1 multiplied by 4, that is 4. 13 when I add them up. So the answer for row 2, column 2 is 13. Let's do the last one and check if our answers are correct. Okay, so the last one, it's row 2, column 3, row 2, column 3. When we multiply, left to right, top to bottom. Okay, so let's do the multiplication. It's 3 times 1, that's 3. And then it's 1 times 1, that is 1. Add them up, you get 4. And there we go. The last entry is 4. And there we go. Congratulations, you've just performed matrix multiplication. Okay, so that's how simple it is. Okay, the key thing is to identify what entry you are trying to find, circling those corresponding rows and columns in your constituent matrix, and then just performing the addition properly. Because in this example, you notice they all had positive signs. It does become a bit tricky when you have negative signs, but with practice, you should be able to do this even faster without even needing to circle it. You could even do it mentally. So this here, this is the matrix A, B.